Hey there, in this video we're going to take a look at square roots and also make clear the distinction between what we mean when we're talking about square roots in general compared to this symbol that we see, which is called the principal root. So where square roots come from is trying to find answers to quadratic equations that have something squared in them. So let's solve this quadratic equation and see what we get. We can use the inverse operation, -4, subtracting 4 from both sides of this equation to cancel out that plus 4, and that gives us x squared equals 9. So this expression, or equation rather, means a number times itself is equal to 9. So we've got to figure out what number that is. Well, we know that 3 times 3 is equal to 9, so that gives us the answer x is equal to 3. If x times x is 9, then x is 3. But you might be thinking, well, that's not the only answer. There's another possibility that works here. If we multiply -3 times -3, that also equals +9. So this equation has two answers, x equals 3 and x equals -3. Or another way that we can write that more concisely is x equals plus or minus 3. That means both the positive and negative answer. So when we're dealing with square roots, trying to find what number times itself is equal to a number, there are always going to be two options, just a positive or a negative of the same number. To give ourselves another tool we can use when we're solving equations like this, we introduce this symbol for the principal root of a number, just in the same way that there is a function, subtraction, that we can use as the inverse of addition. There is a function taking the square root of something that we can use as the inverse of squaring something. So in the same way that +4 and -4 cancel out, the square of something and the square root of something cancel out. Well, what if we're not dealing with an entire equation, but we just want to simplify an expression like this? If I just write square root of 9 using this principal root symbol. Since we just saw that there are really two numbers that we could possibly multiply to get +9, is this square root of 9, well, should that be +3 or -3? If we want to define the principal root as a function, then technically we need to make it so that this function has one clearly defined output, so that there is always one answer we're looking for when we apply this function. So although it is true that every number has two possible square roots, this symbol, the principal root, for the sake of using it as a function, we're going to define that the principal root just means the positive answer unless we state otherwise. So if I just write something like the square root of 4 using this principal root, we know that +2 times +2 or -2 times -2 equals 4. But technically, if we're using this symbol to write this expression, we're going to say that we're using the positive answer here, which is +2. Or if we take the principal root of 16, that means the positive option, that if we multiply it times itself, would equal 16, which is +4. So the principal root symbol on its own tells us to take the positive square root of a number, even though every positive number actually has two possible square roots, with one of them being negative. So I know this is a bit of a technical distinction here, but if we are trying to solve an equation like x squared equals 4, solving an equation means we want to find all possible answers for x that could work. So the solution to x squared equals 4 is both the positive and negative square root of 4, plus or minus 2. Or if we want to solve the equation x squared equals 16, the solutions to that equation are both of the square roots of 16, the positive and negative. So to summarize, the difference between solving an equation versus taking the principal root of a number. If we solve an equation like x squared equals 9, we're trying to find all possible answers that will work, and any positive number has two possible square roots, a positive or a negative. But if we just write the principal root on its own, and we don't have an entire equation that we're solving, but we just write this as a number, principal root of 9, that means we're just taking the positive square root of 9. Now 9 is a perfect square, meaning there is an integer, a whole number, that we can multiply times itself to get 9. But we can also take square roots of values that are not perfect squares. Like if I wanted to solve the equation x squared equals 15, we can use the principal root function to cancel out this square, and x would equal the square root of 15. But since we had an equation here that we're trying to solve, that means we want to find both possible answers, the positive and negative square root of 15. We cannot simplify this any further without turning it into a decimal, so we could just leave our final answer as positive and negative square root of 15. Whereas if we didn't have an equation we're trying to solve, but just this number on its own, the square root of 15, that means just the positive square root of 15. Well, what about if we want to take the square root of a negative number, like negative 15? Stay tuned for that, and we'll check that out in another video.